Welcome to this presentation on raw material for lyocell fiber production. Lyocell is a modern regenerated cellulose fiber known for its high strength, softness, and environmental advantages. The most important raw material for lyocell production is high-purity cellulose obtained from dissolving wood pulp. In this presentation, we will understand the sources of cellulose, pulp manufacturing, purification, quality requirements, and preparation steps before dissolution. The primary raw materials for lyocell production are hardwood species such as eucalyptus and beech. Wood contains cellulose, lignin, and hemicellulose. Since only cellulose is required for fiber production, lignin and hemicellulose must be removed during pulping and purification. The target is to obtain dissolving pulp with cellulose purity of at least 90 to 94%. Cotton linters can also be used as an alternative source because of their high alpha cellulose content. The first major step is pulping. In kraft pulping, wood chips are treated with sodium hydroxide and sodium sulfide. These chemicals dissolve lignin and separate cellulose fibers. The objective is to reduce the residual lignin content to a very low level, indicated by a kappa number below 2. An important feature of this process is chemical recovery, where sodium hydroxide and sodium sulfide are regenerated and reused, improving both economy and sustainability. After pulping, the cellulose pulp is bleached and purified. Chlorine dioxide is commonly used to remove remaining color bodies and impurities. The target is to achieve brightness above 88% and ash content below 0.2%. This high level of purity is essential because impurities can negatively affect dissolution and fiber quality in the lyocell process. Once purified, the pulp is dried and converted into sheets. The moisture content is typically maintained between 6 and 8%. Within the sheet, cellulose molecules are held together by hydrogen bonds, providing sufficient strength for handling and transportation. Proper drying and sheet formation ensure consistent performance during the dissolution stage. Before dissolution, the dried pulp sheets are cut into smaller pieces or chips. Typically, the chips are about 2 to 5 centimeters in size and 2 to 3 millimeters thick. This size reduction increases the surface area available to the solvent. Uniform chip size helps achieve faster and more homogeneous dissolution in the NMO solvent. Pulp quality is evaluated using several important parameters. The cellulose purity should be between 90 and 94%. The degree of polymerization, or DP, should generally be between 400 and 600 for efficient fiber formation. Viscosity is another critical parameter, usually maintained between 400–600 milliliters per g. It is a viscosity number obtained by dissolving cellulose in a standard solvent, usually CED, cupriethylene diamine. These properties ensure smooth dissolution and stable lyocell spinning performance. Several pre-treatment methods can improve the dissolution behavior of cellulose. Mechanical refining increases the surface area of the pulp. Enzymatic treatment with cellulase slightly reduces cellulose chain length, lowering viscosity and improving processability. Ultrasonication can disrupt hydrogen bonding within the cellulose structure, enhancing solvent penetration and accelerating dissolution. These treatments help produce a more uniform spinning dope. Proper preparation of cellulose is essential for successful lyocell production. The goal is to achieve rapid dissolution, typically in less than 30 minutes, and a swelling ratio greater than 1.5. When cellulose interacts with water or NMO solvent, swelling occurs, allowing solvent molecules to penetrate the structure. Good preparation results in homogeneous dissolution and consistent fiber quality. Let us summarize the key points. The production of lyocell begins with high-purity cellulose obtained from wood pulp or cotton linters. Pulping removes lignin, bleaching improves purity, and pre-treatment optimizes dissolution characteristics. The ideal cellulose has a DP of 400 to 600 and viscosity of 400–600 ml/g. It is a viscosity number obtained by dissolving cellulose in a standard solvent, usually CED, cupriethylene diamine. Efficient solvent recovery, typically above 95%, makes the process environmentally friendly and economical. In conclusion, careful preparation of the raw material is the foundation of producing high-quality lyocell fiber. Thank you for watching. Please like, share, and subscribe to the channel for more technical videos on fiber manufacturing and cellulose technology.